Hello viewers, welcome to my channel. So today we'll talk about Bloom filters. So before getting to know about Bloom filter, let's first understand one use case. So we have a database here and it is having the user profiles stored in that particular database. And now a lot of new clients are trying to fill the sign up form. And each sign up form will have a different categories like username, password, address, phone number, age. And while the user is filling this sign up form, we wanted to make that username should be unique. So whenever the user type the username, suppose he's typed the Tom, then the request will go to the application server here, and the application server will contact to the database to check that particular username exists or not, and then it will return the response to the application server, and it can confirm the user is valid username. So this approach will work, right? So what is the problem in this case? The problem here is it is very slow. For each user, we have to validate it. And if it is existing, we have to indicate this username already exists. You need to try with the other username. So this is kind of a very slow and very bad user experience. So can we improve further here? Yes, definitely we can improve. So what can we do? We can store that particular table which is having the already the user profile to this cache, and we can validate from the cache itself. So now the request will come to the cache for validation of the username exist or not. So is this solution will work? Definitely it will work, but what is the problem? Face some more challenges again here. Suppose it is having the 100 row here and 100 row here we have copied into the cache. Now in the database it become 200. So what is happening now? The username whatever we have to check, that is not present to the cache. Half are present to the cache, half was present to the DB. Then again we have to go to the DB and check and get confirmed the username exists or not. So again we went back to the same problem, right? So this is the problem. We want it to be like something where we wanted to check that that particular element is present or not present, right? So that kind of a data structure we want, that is a memory efficient and storage efficient also. To solve this problem, we have to use a Bloom filter. Now let's understand what is Bloom filters. It is a space efficient probabilistic data structure which tell us whether the element may be present into the set or it is definitely not present. So let's try to understand with one example. Suppose we wanted to check first here key 1 is present or not. Then we are asking for the Bloom filter, is the key 1 is present? The Bloom filter is saying no, it is not present. So in this case Bloom filter is returning the correct result, okay, and it is not having the value, that's why it is negative, right? So in this scenario we don't need a storage access because Bloom filter is saying definitely it is not present. So in the second case, when you wanted to check key 2 is present, then Bloom filter is saying yes it is present. It means the value is true, it might be present, and it is positive because it is saying the result might be exist, right? So in this scenario we have to make the storage access for one more level of access. We have another case when we want to check key 3 is present or not in the Bloom filter, then it says yes it is present. Actual case the key 3 is not present but Bloom filter is saying it is yes, so we have to make the unnecessary storage access, right? In this case, that's why it is saying the value is not there but it is still saying the value is present. So Bloom filter can result false positives. Here I have mentioned two types of filtering result can be obtained from the Bloom filter. First one, element might not be present, so it's kind of a true negative. Definitely it will be not present, it means that it is saying true the right result, and negative it means value is not there, right? And when it says it might be present in the second scenario, then it could lead to possibilities. One with the true positive, it means the value is present, right? And another one is a false positive, it means it is saying yes but value is not present. So this is how the Bloom filter works. So let's understand more in deep about the Bloom filter. So let's understand how Bloom filter will work. So in Bloom filter, it is a kind of a bit array with all the bit are initialized to 0, and to add or such element from the Bloom filter, we have to pass through khash function. So let's understand through one example. So here I have declared a bit array with a size of 10. So all our value is 0 here, and I have made the index from 0 to 9. Let's understand by adding few elements into the Bloom filter. So first we are adding the system. We are passing that system to the 3 hash function, and we wanted the value should be in range. That's why we are doing modulo 10 to each hash function, so that will result the value. So first our hash function will return 1. So at 1 index will flip the value. Second hash function return 4. So at 4 index will flip the value. Third hash function will return 7. So at 7 index will flip the value. Now after that, let's try to add design into the Bloom filter. So now again we'll pass with the 3 hash function. So first will return 7. So 7 is already flipped by earlier adding the system, so we'll not flip it again. So we'll check the second hash function. Second function hash function is running 8. So at position 8 we'll make it 1. Third hash function is running 9. So at 9 we'll make it 1. So now we have added a system and design to the Bloom filter. Now let's check the system is present to the Bloom filter or not. So how to check it? Again, we have to pass with the 3 hash function and collect the values from the each indexes. So first hash function is returning 1, so we'll collect the value from index 1. Second hash function is returning value 4, so we'll collect the index value from index 4. Third value is returning index 7, so we'll collect the value from index 7. So we'll see all the values are 1. It means the element might be present into the set. That's what Bloom filter will implies, indicating all three. So now let's check one more example here. When we try to check the coding is present or not, so again we'll pass through the 3 hash function. And so first hash function will return 6, so we'll collect the value from 6. Second hash function return value 7, so we'll have collect the value from 7. Third hash function return 8, so we'll collect the value from the 8. So it will return 0 1 1. So any of the bit is 0, it means definitely the element is not present into the set. So that's what the Bloom filter will imply here, right? And let's check one more scenario here. Suppose we are checking vk is present or not, so we'll again pass with the 3 hash function and we'll correct the value again. So first hash function will return 7, so we'll correct the value from 7. Second hash function returns 8, so we'll correct the value from 8. Third hash function return 9, so we'll correct the value from 9. So all the values are 1 1, right? It means the values are present into the Bloom filter. But as you see here, we have only added a system and the design into the Bloom filter. We have not added a VKS into the Bloom filter. It means it is giving a false positive result. So in Bloom filter, false positive results are expected because we are getting trade-off here between the less memory and less storage compared to the accuracy. Now let's see the advantages of the Bloom filter. So first advantage of the Bloom filter can used in a first layer of caching, and it only require a constant space. So how we can avoid expensive database query by using the Bloom filter? So application will first check with the Bloom filter if the value exists or not. If the values exist, then only can check with the DB. If the value is not exist, then it will not check with the DB. So that's how it can optimize the optimum query with the database. In second, it can avoid one hit wonder while the caching from the storage, like in the CDN, right? Only the second request can be cached. Suppose we have a CDN here and we have a storage here, we have an application, right? And if application is requesting first time something, then will not cache it. When the application will requesting second time, then only will cache it. Because one hit wonder, it means like something is unusual or very uniquely searched by the customer. That is not required for frequent access for the mass users. So that's why we wanted to cache the web objects from the storage to the CDN or the local store only via in second request. So Bloom filter will help to resolve that issue. And third one is the Google Chrome also uses the Bloom filter to check the malicious URLs. So how it will check? So suppose we have a Google Chrome here, it will first check with the Bloom filter. If it says no, that URL is not malicious, then it is really good. But it says it might be malicious, then it goes to the backend and it will do the full scanning of that particular URL for malicious check. And the fourth one is the Quora also uses a said Bloom filter in the feed backend to filter out the story that people have seen it before or not, right? So next, Redis, Bloom and the Apache Spark also uses a murmur hash, and the InfluxDB uses the access hash. This will distribute uniformly into the Bloom filter while adding the element into the Bloom filter. Next one we can avoid the false positive by choosing the correct size of Bloom filter based on the number of expected element to be entered into the Bloom filter. So this size we have to choose according to that, right? Based on this size, the false positive can be avoided, and the number of element expected into the Bloom filter, that we have so also consider it to avoid the false positive. And it is a kind of a trade-off between the less memory to the accuracy, right? So here the less memory and storage is winning compared to the accuracy. So this is all about the Bloom filter. So do subscribe my channel to get to know more about interesting topic on the system design.